Welcome to my channel of mathematics videos. My name is Karen Daly and I am a mathematics lecturer at DKIT, a third level college in Ireland. This suite of videos was produced to help students beginning their third level career brush up on their basic mathematical skills. This video is on rounding numbers. Enjoy! There is a special number in mathematics called pi, and it has the symbol pi. And if on the calculator I was to press the button for pi, I would get the value 3.141592654. The calculator has provided me with an approximate value for pi, correct to 10 significant figures or 9 decimal places. The value is approximate because in fact there are lots of other digits to be displayed out here, but the calculator doesn't display them due to the size of the screen. We use the terms significant figures and decimal places to display the accuracy of the number. Let's look at how that's done. Significant figures first. It says that there are 10 significant figures. To count the number of significant figures in a number, we begin at the first non-zero digit, which in this case is a 3, and we count every digit, including this one, throughout the number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 significant digits or figures in this number. How about decimal places? It says there are 9 decimal places. Well, we go and we count every digit after the decimal point. So the decimal point is here, and we count every digit after that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 decimal places. So to recap, to find the number of significant figures in a number, what you do is you count all the figures in the number beginning from the first non-zero digit. So remember, count only from the first non-zero digit and count all the numbers after that. To find the number of decimal places that there are significant in a number, you count all the figures after the decimal point. Let's look at this problem. How many significant figures are the numbers 5.03240 and 0.0456 correct to? Okay, let's look at the solution for part A. Count the number of significant figures in a number. We start at the first non-zero digit and we count every digit including this. So here we've got 1, 2, 3, 4, 5, 6. There are 6 digits in the number. So for part A, it's correct to 6 significant figures. Now let's look at part B. Now remember, we start counting at the first non-zero digit. Now this digit here is 0, this digit here is 0, so our counting only begins at the first non-zero digit, which is the 4, and we count all the digits including this one, so we'll have 1, 2, 3. So the answer to part B is 3 significant figures. Now, can I ask you to pause the video again and repeat the same question, except this time tell me how many decimal places these two numbers are correct to. Okay, if we look at part A, to find the number of decimal places a number is correct to, you count every digit after the decimal point. So we begin at the 0, that's the first one, 1, 2, 3, 4, 5. So this number is correct to 5 decimal places. If we look at the second one, part B, again you start counting every digit after the decimal place. So the first digit after the decimal place will be a 0, that'll be the first, then a 4, 2, 3, 4. So there's 4 digits after the decimal place, so the part B is accurate to 4 decimal places. Recall the pi value that was displayed on the calculator. Now sometimes we don't need even this amount of accuracy within a calculation, and what we then have to do is round this number to so many significant figures or so many decimal places. So let me show you how to do that. Let's say I was asked the question, round the number above to one significant figure. Now, the rounding convention is as follows. If the figure to the right of the figure being rounded is less than 5, then we leave that figure being rounded alone. Otherwise, we're going to add 1 to the figure being rounded. So let's do that for this question. So pi is this value here, and I want to round it to one significant figure using my rounding convention. So here's one significant figure here. So I go to the digit to the right of it, which is this figure here. It's a 1. And then the rounding convention says if the number to the right of the one being rounded is less than 5, which it is, then I leave the figure to be rounded alone. So the answer of pi to 1 sig fig is that pi is equal to 3. Now if I round pi to two significant figures, what will it be? Well, the two significant figures are going to be the 3 and the 1, right? But to see what it rounds to, I go to the one to the right of it, and the one to the right of it is a 4. It's less than 5, so then I just leave the one being rounded alone. So the answer is to two significant figures, pi is equal to 3.1. Let's repeat the question again and round pi to three significant figures. Okay, the three significant figures will be 1, 2, 3. You go to the digit above the last one, which is a 1, right? And this one is less than 5, so it'll have no effect on the 4. So to three significant figures, pi is equal to 3.14. Let's repeat this and round this number to four significant figures. So let's count the four significant figures. That's the 3, the 1, the 4, and the 1. Now what it says, the rounding convention says go to the figure above it, and the figure above it is a 5. Now this is different from we had before, because the rounding convention says if the number is 5 or greater, we have to add 1 to the figure that's being rounded. So the answer we get here is that pi is equal to 3.14, and we add 1 to the 1 because of the 5, and we're going to get a 2. Let's repeat that just one more time, and we'll round this number to 5 significant figures. So let me underline the 5. 1, 2, 3, 4, 5, right? You go to the one to the right of it, which is a 9, and if it's 5 or greater, we have to add 1. So the answer is going to be pi is equal to 3.141, and we're going to have to add 1 to the 5, so we get 6. The good news is that the rounding convention is the same whether we're rounding to so many significant figures or so many decimal places. So when we rounded to one sig fig and we got pi is equal to 3, that's the same thing as rounding to no decimal place. Pi equal to 3.1 is the number rounded to 1 decimal place. Pi equal to 3.14 is the number rounded to 2 decimal places. Pi equal to 3.142 is the number rounded to 3 decimal places. And lastly, pi equal to 3.1416 is the number rounded to 4 decimal places. What I'd like you to do now is to pause the video and to try this problem yourself. Round A, this number, and B, this number, to 3 significant figures. Then when you're finished, turn the video back on and I'll go through the solution with you. Okay, let's look at the solution for A. I want to round it to 3 significant figures, so if I highlight the 3 significant figures, you start counting from the first non-zero digit. So the first non-zero digit is a 4, so that's the first, the second, and the third. And to round it to 3 significant figures, I go to the figure to the right of it, and the figure to the right of it is a 4. And if that number, which it is, less than 5, then I just leave the 6 alone. So the answer to 3 significant figures for part A is 0.456. Now let's look at the answer for part B. Again, I want to round it to 3 significant figures. So if I highlight the 3 figures, 1, 2, 3. I go to the figure to the right of it, and it's a 9. It's greater than 5. So what I do is I have to add 1 to the digit being rounded. Now if I add 1 to 9, I get 10. Put down 0, carry 1. Add 1 to 4, I get 5. So the answer is going to be 5.50. Make sure that you have added that 0 there. It doesn't change the magnitude of the number, but it does change the accuracy of the number if you don't add it. This number here, as I said, is accurate to 3 significant figures. 1, 2, 3. What I'd like you to do now is just to pause the video and try this question here. Round these two numbers to 4 decimal places. Then when you're finished, turn the video back on and I'll go through the answer with you. Rounding part A to 4 decimal places. If I count the decimal places, 1, 2, 3, 4. And if I go to the digit to the right of it, it's a 9. It's greater than 5, so you're going to add 1 to the 4. So the answer to part A is 0.4565. If I do the same for part B, the number of decimal places is 4, so if I count them, 1, 2, 3, 4. If I go to the place above it, it's a 9, so it'll add 1 to the digit before it. So adding 1 to 9, you'll get 0, carry 1, 0, carry 1, 0, carry 1, and then 4 plus 1 is 5. So the answer to part B turns out to be 5.5000. It's important to write down these zeros here. And although it doesn't affect the magnitude of the number, it displays the accuracy of the number being accurate to 4 decimal places.